everyone, this is Manasa. I'm a first year BE student from Sri Venkateswara College of Engineering, Bangalore. I come from Department of Computer Science and Engineering. So today I'm doing this video to provide information regarding the three topics which come under applied physics. So the three topics which we are going to discuss now are, the first one comes laser cooling, and the second one is laser finding, and the third one comes barcode scanner. So we are able to see the related images of these three on the screen. So now let's get into the first topic, that is laser cooling. So the first topic, laser cooling. What is laser cooling? Laser cooling is a multi-process that includes a number of techniques in which atomic and molecular samples are cooled down to temperature near absolute zero. The next, these techniques depend on the fact that when an object, which is usually an atom, re-emits a photon, a particle of light, its momentum is subject to change. So for a combination of particles, their thermodynamic temperature is proportional to the variance in their particle velocity. So this means that more homogeneous velocities among particles correspond to the lower temperature. Let's deal. So the laser cooling techniques used in the process of laser cooling combine atomic spectroscopy with the mechanical effect of light so as to compress the distribution of velocity of particles, thus leading to the cooling of the particles. Laser cooling is not meant to be the cooling of lasers, but rather the use of dissipative light forces for reducing the random motion and thus the temperature of small particles, typically atoms or ions. So now let's get into a visual video and then let's come back. So here a gas of helium atom is cooled by the laser cooling technology. So our next topic comes laser finding. Let's get into that. Laser finding. So what is laser finding? So laser finders are the devices containing a laser with which one can measure the distance to an object. Typically, such a device works either with the direct time of light or with the phase shift method. Some can measure object distances of multiple kilometers while others are designed for much smaller distances. For example, within a building, often the object distance appears on a digital display. So when compared to the ultrasonic or radio and microwave frequency devices, the main advantage of this laser distance measurement technique is that laser light has much smaller wavelength, allowing one to send out a much more concentrated probe beam and thus to achieve a higher transverse spatial resolution. So the advanced viewing devices, probably with variable magnification, make it easier to identify and precisely target certain objects. So now let's see a laser range finder which is used by the army men. So our next topic comes barcode scanner. So laser barcode scanners use a visible and repetitive flashing laser light beam commonly used to tackle inventory and to enter purchases into a computerized management system. The scanner is a wonderful tool for providing fast and easy customer service in places like supermarkets or restaurants or many other places. They all read the black and white striations that comprise a barcode. So these combination represents an item's unique identifying attribute, typically a combination of numbers and letters. So by capturing this data, the barcode either decodes it initially or send it to an external decoder. A light source renders the barcode readable, a lens captures the image, a photoconductor translates the image into electronic data. A decoder translates the data into the selected language and then sends it to the scanner's output port. The laser barcode reader is the most commonly used barcode reader. So this is how the laser reads the barcode, which is represented by numbers in many supermarkets or the restaurants where we see this type of barcode reader.